Hi, my name's Ansel. Today I'm going to be going over the origins of Bayesian probability. We're going to talk about how faith, philosophy, and science are interconnected. We're going to cover Bayes' theorem, the historical context that led up to that, how his Christian beliefs shaped the way his scientific endeavors took place, and then we're going to shift over to how the modern implications of using Bayes' theorem in machine learning and artificial intelligence. One of the first things I like to point out about Bayes' theorem is it's a lot more than just a math problem. It's a shift in thinking, a way of reframing problems. And the traditional frequentists might say something like, what is the probability of our data given a hypothesis? So here, it's going to be a yes or a no. We're either going to accept or reject that the probability of our data matches our hypothesis. But in a Bayesian mindset, we're going to shift to a likelihood on the hypothesis. We're going to treat the hypothesis like a measure of belief. What is the probability of our hypothesis given some data? So we're going to look at the data and we're going to say, okay, how credible, how confident can we be that our hypothesis is correct? Is it 85? Is it 95% correct? And this is a lot different way of looking. We're looking at the way we learn, and then what can we do to update so that our hypothesis is more correct? And that's where the Bayes' theorem comes in. So the Bayes' theorem was developed by Thomas Bayes in the 1700s, and he allows us to put in our initial beliefs and then update our new beliefs based off of evidence given. So we're going to look at new evidence and we're going to update and have new beliefs. And this is how he came up with it. Over here on the right-hand side, you'll see this is a little image where I'm trying to represent his geometrical thinking problem, that how he came up with this. He imagined a ball being randomly put on the table, and it had an unknown probability of landing there. And so afterwards, he repeatedly threw balls on the table. Some landed on the right, colored red, and some landed on the left, colored blue. He then computed the probability of where all those balls were, based on their position, and then took the position of all those balls and then computes where that hidden ball was most likely to land. And this is how we got this equation that kind of gives us these new beliefs. But what are these new beliefs really called? Well, this is what the math equation really looks like. And we call that the posterior. These are our updated beliefs. So we can interject prior beliefs, whether they have some kind of subjective bias to it, or they're just unknown, and it's more like a flat line. And then this is your traditional frequentist approach right here. Hey, what's the probability of our evidence given our hypothesis? And then when we multiply those and divide it by the overall probability of everything, now we have this new belief. But you'll see it's flipped over here. We're saying, hey, this is the inverse statistical thinking right here. We're saying, what's the probability of our hypothesis now based on or given the evidence? And Bayesian theorem or Bayesian statistics is actually meant to be done in an iterative approach. So you would take this posterior and you will make it the new prior. And you would repeat the process. So you would refine your beliefs based off of the new evidence, and you would learn what what is the most likely probability of our hypothesis. So how did he get here? What pushed him into learning this? Well, the historical context was the Age of Enlightenment, and there was an emphasis on human reasoning, scientific experimentation, empirical evidence, and there also was a rise in Christian skepticism. Bayesian statistics really comes more of an inductive approach to thinking. There's a bunch of great characters during this time, but I'm only going to bring up a few. One of my favorites is Sir Isaac Newton. He believed that the laws of nature could be represented mathematically. And he had this famous saying where he said, hey, I form no hypothesis. And he was meaning that, hey, we don't invent explanations without empirical evidence, some experiments, and some mathematical equations to prove it. And so that's what he did. He would observe a phenomenon in nature. He would derive mathematical principles or an equation, and then he would confirm that those were correct on further observation and testing. That's how he would refine it. And this is the basis of modern science and the scientific method too. So is it observable? Is it repeatable? And is it predictable? Now Bayes, he followed in his footsteps. He had he was thinking very similar to scientific rationalism, but as Newton described how the world was mathematically, Bayes was describing how do we learn about the world? And can we have a math equation that provides us confidence and credibility in our beliefs? And what really pushed him into this was there was an antagonist at the time, and he was a beautiful writer. His name is David Hume. Now, David Hume, huge skeptic. He's a philosophical skeptic and really founded it. And he believed that we could only really count on our subjective senses. And all other observations of causations was something that we made up in our mind. It was something we connected. However, it did not mean that that's how it was in reality. And his writings sparked a lot of controversy. He inspired many philosophers, scientists, and mathematicians to rebuttal his claims or continue his claims in some regards. But he was most famous for this section 10 in his inquiry concerning human reasonings of miracles. And this is because he was saying that miracles couldn't be proven empirically or empirically justified. And if a miracle couldn't be proven, then maybe the deity behind the miracle couldn't be either. And it's not unreasonable or unrational, his thinking. I think he contributed quite a bit to thinking as well. So he's like, is it more probable that a miracle happened, or is it more probable that people were deceived that a miracle happened or believed that that miracle happened? And I think that's a reasonable question to ask. However, it sparked a lot of debate during his time, and that's when that kind of set the stage for Bayes. But 2 years after Bayes passed away, Richard Price kind of pushed his work forward, presented the manuscript to the Royal Society. It was called An Essay of Solving Problems to the Doctrine of Chances. And he's using intelligent design to argue that there is such a deity or there is a God. And I got the excerpt right here. You'll see he's like, hey, I'm proposing that we show what we reason to have believing a constitution, that there are fixed laws. Basically, the laws of nature are fixed. He's following Newtonian thinking here. And he's saying, hey, the frame of the world is affected wisdom, power, and has an intelligence cause. Therefore, in his mind, the existence of a deity as well. He went one step further. And down here, I like the best part of it. He's saying, hey, the particular order of reoccurring events, the reason to think that such a reoccurrence or order is derived from stable causes is or regulations data. This is not from irregularities of chance. So he's saying, hey, the beauty, the order of life, it's best explained by intelligence rather than chance. And he didn't come up with these ideas on his own. This is actually reflected in Christian beliefs. Now, there's a lot of different scriptures I probably could have picked, but I'm just going to stick with Romans 1:20. And this is where the Apostle Paul, he says, for since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen and been understood from that which have been made, so that people are without excuse. He's saying, hey, all of creation is a testimony that there is a God, that order, that beauty. And so this is a Christian belief that affected the scientific rationalism, and still to this day. And I would say that faith and science is connected. There is quite a bit of interplay, and I believe they're trying to answer some latent questions like what is truth? What is identity? What is purpose? Do we have accountability? Here's what I mean by it. I put Ikigai over here, but I think Ikigai doesn't show us maybe like divine duty and things like that. But it's a great Japanese structure to help you find purpose. However, what I'm trying to say is the relationship, how two things are connected, helps you answer that latent question. Um, so let's just say I've got this calculator, and it's a great tool in its relationship with me. However, if this calculator is by itself, I mean, it might as well be a paperweight because it has no purpose without me. And that's what I'm trying to say is in faith and science, that road to discovery is the purpose. And I believe it's doing God's work. I actually threw this up there. There's this cool verse in John 17:3. It says, "This is eternal life, to know God and Jesus the Messiah whom he sent." And I may have a little bit of a expanded thought on this, but I think discovering the order, discovering creation is a part of eternal life. It's like getting the purpose, feeling it out. And so from this work, seeking and finding, asking the questions, receiving, we can find more than a formula. We got a theory of rationality. We've got a framework of dealing with uncertainty, and we have a mathematical way to bridge our belief from evidence. And this is an amazing thing. And it's still into effect to this day. I mean, modern implications of this is done in machine learning and AI. We can use, we have naive Bayes classifier, and this is where we're taking like large language models and we're classifying text by categorizing it. And we can use it for a lot of things, but one of the most popular things is email spam filtering. And then Bayesian statistics goes into Bayesian optimization. So this kind of builds a probabilistic model. If you have an overfitted model with a lot of noise, what this will do is it'll find some of those promising points and it'll kind of move out some of those extra points. It'll help become a better fitting model. And this can do a couple of things. This can reduce the cost of computations, and obviously reducing the noise as well. We have Bayesian belief networks. Now, this is like a graphing language. I think of a graphing database when I think of this, but it is graphical model where it shows different nodes, and it's going to represent the best probability between their relationships. And this is really good for decision systems like medical diagnosis or fault detections, things like that. You also could do like anomaly detection with it, so you could like find outliers to maybe like do a little more research on and see what that data could tell you. We can use it for personalization. This could be personalization of marketing. It also could be social media accounts, like what kind of videos, what kind of content do you like? So we can use Bayesian statistics for that. And the last one I put here is sensor fusion. So this is taking a bunch of sensor data and it's creating a model that estimates maybe the robot in its current environment. So like the state of the robot, it can combine a couple different things and then output, a specific state of that. Now, I think this Bayesian statistics is going to continue to influence the world that we're in now. And I think how I'd like to end this is on that our beliefs matter. And I think we can thank Thomas Bayes and Richard Price for giving us an equation to be able to model that. Like how do we change our beliefs based off new data? And we should always update our beliefs as we learn more. And how can our beliefs affect the world? Like our beliefs affect our behavior, and our behavior changes the world. And so maybe I'll leave it that. Like how can we continue to use this to update our own beliefs and make the world better? Thank you. Hope you enjoyed this.